Well, thank you everyone for joining me for this installment of VELP Scientifica series. Today we're going to be talking about our SCR 158 and the product showcase around there. This is VELP's solvent extraction system. And first, one of the things we should go over is what is solvent extraction, right? So, solvent extraction is a technique used to separate mixtures based on their solubility of their components in a specific solvent. Specifically, what I want to talk about today is a solid liquid extraction. And that is where a liquid solvent is used to dissolve and remove soluble components from a solid material. Some examples of liquid solvents that you might think of are petroleum ether, hexane, toluene, things of that nature. Now, what's important to note here are some of the official methods. The solvent extraction method is approved by most of those official worldwide organizations and bodies. Examples we're going to be familiar of here in the United States are going to be our AOAC, EPA, ASTM, and different bodies of that nature. Now, what's important to note with solvent extraction and the analysis with it, when it's according to the standard and official methods, there are three main things that need to be standardized. The first is going to be the size and amount of the grinded and homogenized sample. It's really important to remember, which is true with most any analytical techniques. The more homogenized the sample is, the more repeatable and reproducible the results will be. So that's important to note. The second thing will be the type and amount of solvent. Like I mentioned before, this will depend on the official method. Could be something like petroleum ether, hexane, things of those nature, and something that us with our analytical team can also help support you with. And the final thing, which might be the most important, are going to be extraction times. Now, these extraction times are important for a complete and full analysis without overheating or boiling the sample at all. Now, I'll talk a little bit specifically about the solid liquid extraction methods and the different methods that there are. We have Soxhlet, we have Twisselman, as well as Randall, which some people also call hot solvent extraction. Now, in the industry, these methods can be used interchangeably, but there are very important differences that I'd just like to review and make note of here. Now, the traditional way to do this extraction is called Soxhlet. Now, that's where solid samples are extracted with fresh warm solvent that doesn't contain the extract. The sample is not immersed in boiling solvent, but the condensed solvent passes through the thimble. This is a more traditional method that typically can take anywhere from 15, 16, sometimes 18 hours for an analysis. So, in the past few decades, a few different methods have come out. One is going to be the Twisselman method, and that's where hot extraction with the solvent flowing through the sample in the thimble, but the sample is not immersed. And then finally, we have our Randall or our hot solvent extraction technique. Now, hot extraction by immersing the thimbles into the boiling solvent to optimize speed and solvent consumption. This is really important because this is what's going to speed up the analysis as well as get the most efficient extraction during the analysis. And that's why VELP, when we developed our SCR 158, made a choice, and that choice was the Randall technique, again, to make sure the sample is fully immersed as well as at the end rinsed out to make sure we get a full extraction with those solid samples. Now, kind of what I was mentioning before, some of those hot solvent extraction benefits compared to traditional Soxhlet involve rapid extractions. So typical extraction time with a hot extraction might only be, hour and a half to 3 hours, somewhere in that time frame. So as you know, it's much more efficient than with the traditional Soxhlet method. There's a lower solvent consumption with this. Now, that has to do with the specified amount being used as well as the actual solvent recovery. Now, with our SCR 158, your typical solvent recovery can be up to 90%, and you're able to reuse that solvent for subsequent analysis. And the nice thing is, with the hot extraction, you're still not giving up any application range, repeatability, or reliability with hot extraction versus the traditional Soxhlet method. Now, we do have a wide range of matrices that we can cover under this. So think about lots of different things with fats and oils. Primary focus and what we see the most of in the industry is going to be under food and feed. Things like food labeling, quality control, quality assurance, research and development, things of that nature. But we also do see a large role in the chemical, environmental, and agricultural industries, right? Things like pollution monitoring and PCBs, things like fertilizers, legal compliance for chemicals, and solvent extraction has an important role to play in all of these different fields. Now, there are two different ways that the solvent extractor or SCR 158 is used for gravimetric determination as well as for qualitative determination as well. So, like I mentioned before, one of the primary focuses of this instrument is for food and feed when we think of crude fat as well as total fat. But it is important to know it's not only for food, right? Those environmental applications I was talking about earlier. So, PCBs, oil and greases and sludge for wastewater plants, things of that nature. Agriculture, when I think about using fat coatings for artificial fertilizers, we definitely see that a lot. Um, Chemical is another good example for the residues of resin papers, insulating wools, and more specifically, we're seeing a growing emergence of oil determination and recycled PET. And then finally, as well, something to note is the textile industries. So, oil determination in leather and synthetic fibers, things of that nature. Now, like I mentioned, this can also be used for sample prep and extractable matter analysis. So, if you're wanting this to, extract an oil from a sample to then be further analyzed via GC, mass spec, things like that. This is also going to be something you can use. And again, these are some of the applications we already talked about, but micropollutants in rocks, coating of fertilizers, as well as cannabinoids extraction for further analysis, chemicals we've already talked about, as well as textiles, that colorant on textile fibers. So I wanted to go over our SCR 158 briefly, just so everybody's aware of what's included. There's a few different things I like to mention with this system. It talks about versatility, safety, and smart and intuitive. Now, with one control pad, which you can see there on the slide, you can control up to 4 SCR 158s with one, and that actually over time leads to a reduced cost per position because you're only having to buy one control pad. It works with all different types of samples that we discussed. And what's nice to know is we have 3 different extraction cups, 3 different thimbles, as well as 3 different seals. So there's a wide range of solvents, sample types, sizes that we're able to work with. What's really nice about this system is our Solvent Express technology. So with this system and for lab operator safety, you're actually not going to be able or not going to have to touch any solvent individually. So with this system, you can put it directly into the system without ever actually having a lab tech touch the solvent. So that's really good. Another thing about safety is going to be that safe end technology. So once the analysis is complete, the cups will actually raise up from the heating block, and that way there's no burning of the sample or anything of that nature. There are different warning signals, safeguards, things of that nature, as well as an internal tank with cooling so the system never overheats. Um, like I mentioned, that control pad, you're able to completely control the instrument through this control pad for analysis times, data export, and things of that nature. We have many pre-installed methods as well as the ability to customize methods. And you have direct access to the archive of your data, also from remote through our Hermes cloud connectivity, which I'll talk about here shortly. Now, the last thing I'll mention that's really unique about our system are our patented titanium condensers. Now, this ensures minimal water consumption and condensation, but it also leads to a more efficient extraction, right? Titanium is going to have a higher thermal conductivity than glass. So that's going to lead to a more efficient extraction over time with some of those samples. Now, as I mentioned, we also have our VELP Hermes cloud platform. Now, this is a way to remotely monitor your instrument as well as remote into it diagnostically. And you're also able to export data via LIMS or anything else up into the Microsoft Azure protected cloud. And this allows you to work with your data anywhere at any time. And that's really important when we think about labs with large sample throughput and things of that nature. Now, more about this system is you're able to monitor and control the system in real time, 24/7. You can create reports and manage your data through this. You'll receive notifications and alerts if anything is looking different of the instrument or you want to dive into it more. And you also benefit from enhanced service support. So, with this, our service team is actually able to remote into your instrument, providing us with the quickest turnaround time for service and support in that nature. But thank you very much for taking your time. I appreciate everybody's time, and I hope you have a good rest of your day. Thank you.